Hello, everyone, and welcome back to WYSTEM. My name is ET, and tonight's really special actually for a couple reasons because today we are celebrating Engineering Week. So, if you're now just joining us, this month is all about celebrating what are called the STEM fields in Wyoming. And STEM stands for science, technology, engineering, mathematics. We've had 2 amazing weeks of WYSTEM. In week 1, we did science. We had Dr. Dan and Amy Surdan that run Stitches that talked about viruses and bacteria. Last week was Technology Week, and we had the ever so talented Teal talking to us about maps and the spread of disease and technology. It was super awesome. And then this week, we've even gotten a more awesome curriculum ready for you, which I don't want to spoil anything because I'm going to introduce you to our folks who will be leading us through Engineering Week. But don't worry, if you are now just joining us, you can go back on this YouTube channel and watch the 2 pieces from Science Week and Technology Week whenever you want to, because there is a special participation prize for the WYSTEM initiative, which is each week at some point in the video, there is going to be a little flashing keyword that's going to show up right over here in the screen. You don't know when it's going to show up. It might be this week, it might be tonight, or it might be on Thursday. But what's going to happen is at the end of WYSTEM, which is actually next week, believe it or not, if you know all the secret code words for each of the 4 weeks, so there's 4 of them, you'll put them into a form, and then if you are a Wyoming student, you will have the opportunity next Friday to win a 3D printer for your school, which this week and next week, you're going to learn a lot about 3D printing. So if you like what you're going to see in the next 2 weeks, you're going to want one of these 3D printers, so you definitely want to win it. So definitely go back if you haven't done so already. Watch Science Week, watch Technology Week, and then be on the lookout for the 3rd secret code word, either tonight or Thursday. It's just going to pop up for a few seconds, and then it's going to disappear. So you just got to watch it. And then next week is our last week of WYSTEM, so we're going to be doing mathematics with Lars Kotoff, a computer science professor at the University of Wyoming. And then we will have our final wrap party, which we have a special little thing happening next Friday. You're definitely going to tune in and watch that. And that's also where we're going to draw the lucky person, the lucky student's name to win a 3D printer for their school. So we are just super excited about this initiative. Thank you, Anderson Elementary PTO board and all of our great guest speakers and hosts who have just done an incredible job and taken a lot of time to make WYSTEM what it is. So I have already talked enough because I want to save as much time tonight so that you can be introduced to Tyler Kerr. He'll tell him a little bit about himself, who runs the Makerspace over at the University of Wyoming. Excuse me, as well as ooh, joking in my spit, I talk too much. Brayton Tolman, which you will meet here momentarily. So without further ado, I'm going to hand you off to Tyler. So Tyler, why don't you talk to us about what are we going to be learning this week? So Tyler, over to you at the UW Makerspace.
Sure, thank you, ET. So what we're going to be doing today is learning how to use really popular 3D modeling software called Sculptris to create some really fun 3D models. And so my hope is that this lesson will be super interactive. And that you guys might be able to follow along and create your own awesome 3D models. So with permission, you can download and install Sculptris using the links that are posted in the YouTube description below. And so what we'll be doing today is we're going to be talking a little bit about how Sculptris works. And this is my favorite program to start teaching 3D modeling with because it's pretty easy to get started, but you can make some pretty complex models too. And so this is a really great way to get into the world of 3D modeling before you graduate up to designing 3D models of face masks and face shields. So as an aside, Sculptris is usually easiest to use with a mouse. So do make sure that you have one handy if you can. You can do it with a touchpad, but it can be a little tough. So as you guys get started learning the basics of Sculptris, my friend and coworker Brayton, who's a mechanical engineering student here at UW, is going to start 3D modeling some really cool things while I talk to you guys about engineering, about the different types of engineers that there are, about the engineering design process, and exactly what types of things engineers are doing to combat coronavirus. And I'm going to give you some fun homework, which I know sounds like an oxymoron. How can homework be fun? But I want you guys to download Sculptris and work alongside us to design some amazing models. And even after this is over today, I want you guys to keep designing those models. And if you send us your 3D models before Thursday at 6 p.m. at info@wtcc.tech, we'll have them 3D printed live on air when we talk about how 3D printers work. So if that sounds like a plan, I'm just going to give you guys just a little bit more time to download Sculptris because it is a pretty speedy program to download. And I'll hush for just a second here so we can make sure that folks are caught up and downloading Sculptris. And then we're going to switch right over to Brayton's screen, and we're going to take a look at exactly how to start using the program. But I thought it would be better to have Brayton doing this because he's a much better 3D modeler than I am, and he's also a really accomplished CAD modeler. And we're going to talk about that in just a second. So let's see. So if you guys are ready, we can let folks get caught up, but we're just going to be talking a little bit while people are downloading about some of the differences between different programs that you might be using as a 3D modeler or as a CAD designer or as an engineer. So my background, if you guys remember, my background is not engineering. I am by trade a paleontologist. So that's about as far away from engineering as you can get, but we use a lot of 3D modeling and 3D scanning in paleontology. So I've done that a little bit, but people like Brayton have done a lot of a different type of digital design called computer-aided design. And that's kind of the two different camps of the digital design world. So as you watch Brayton here, you're just going to hear my spooky floating voice as Brayton helps to demonstrate some of the cool things you can do in Sculptris. But in the 3D modeling and digital design world, you have essentially two different types of digital design software. There's something called CAD, or computer-aided design. And you guys might have seen a lot of 3D printed masks or face shields in the news lately. And those were designed in a CAD program, not a 3D modeling program that we're going to be using today. But because 3D modeling with Sculptris is a little bit easier to learn in 30 minutes, it's a really great place to dive into the world of digital design. So what's the difference between 3D modeling and CAD and computer-aided design? Ultimately, it all depends on what you want to do. So CAD software is used when creating industrial, mechanical, precisely measured functional objects. So things like gears or motors or even masks and face shields. So oftentimes those things need to be a certain length or height or thickness so they fit well with other parts. And they also have to sometimes fit safely on somebody's head or face. So those types of projects are typically made in a CAD software. So you can make measurements and you can design them with specific angles or lengths or thicknesses or tolerances in mind. Now, 3D modeling programs like Sculptris are usually used a little bit more in art, used more in organic objects, things like video games or CGI in movies. So with 3D modeling programs, like the one we're going to be using today, you start with a 3D object and you push it and you pull it and you smush it until it's shaped the way that you want. And so what we're going to be doing today is using Sculptris, this digital ball of clay, and we're going to be sculpting it using 9 tools that mimic traditional artistic techniques. And if you guys are ready, we'll do it. We'll switch over and we'll show Brayton's screen here. And let's make sure that we do have to screen share, correct, right? Okay. Alrighty, so what we're gonna do is get started in Sculptris. I'm gonna try my best to channel my Bob Ross impression. But Sculptris is a great free 3D sculpting software that we really like to recommend for anyone who wants to learn the basics of 3D modeling. So if you're new to the world of digital design, Sculptris is the perfect place to get started. It works on almost every computer, and you can even, and this is important for what we're going to be doing, 3D print what you've designed. And remember, I gave you that homework. So if you send us your 3D model before Thursday at 6 p.m., we're going to have them live on air behind us when Brayton and I talk about the 3D printers to show you guys the 3D models that you have designed printing live. And I think that's pretty cool. So let's just go over a couple terms super quickly before we get started. So digital sculptors use lots of special terms like brush or mesh. And when we talk about brushes in 3D modeling, we mean the tools that are used to grab and smush and pull and model the object. So those are brushes. And then the other side of things, when we talk about the word meshes, what we talk about are the 3D objects themselves. So we use brushes like the 9 we're going to be using today to modify and mold and sculpt meshes. So very quickly, we're just going to cover moving around. So if we type P on our keyboard, it's going to turn on a perspective grid that's centered around a pivot point. And this is super helpful for figuring out where you are. So if you can't figure out what side is up or what side is left and right, definitely hit P, toggle that on, and you'll be able to see where you are in space. Now, if you hold left click or right click while you're not touching the digital ball of clay, it allows you to rotate around your object. And if we roll the mouse wheel forward or back, it'll zoom in and out. And if we actually hold Shift and click down on the middle mouse button, it allows you to pan around. So what I'm going to do is if I zoom in here, and let's have Brayton zoom in super close. So if you zoom into a part of your object and you need to pan around, holding Shift and middle mouse button helps you move around the object. And then the last one is if you hold Shift and if you roll the mouse wheel up and down, what you should notice is it'll change the size of your brush. So can you see that your brush there is that orange circumference, that orange circle? So if you wanted to, and we'll talk about it in just a bit, if you wanted to change the size of your brush to grab more of the object, you can definitely do so. So that's the basics of navigation. And if you can see on Brayton's screen, there's a quick help guide on the bottom right side. So if you see there, if you ever forget anything we've taught you, it's right there. And if you ever forget one of the buttons that we're about to teach you, you just hover over them and it'll tell you a quick little hotkey that you can press to toggle them on, as well as kind of a refresher on what that button does. So to start modifying the mesh, we're going to take a look at the top left side of the Sculptress screen. Can you guys see that there's 9 brushes in a 3x3 grid that you can choose from there? So we'll just work our way from the top left all the way down, and we're going to start with the first tool there, which is called Crease. So what Crease does is it chisels a line into the surface of the brush area. So if you see, you can actually carve out little pieces of the area or of the mesh with Crease. So now the next one over is Rotate. So what you can do with Rotate is twist either the brush area or the entire model. And we'll show you in just a bit how you can rotate the entire model. And then next up is Scale. So what you can do is grow or shrink the model or the brush area with the Scale tool. And then next up on the second row is Draw. So what Draw does is lifts the digital clay up from the surface of the model in the brush area. Right next to Draw is a button called Flatten. So what Flatten does is just like the name describes, right? It'll flatten a plane within the brush area. And then next up, right next to Flatten, my favorite tool, and this is the one that I use the most, is one called Grab. So what Grab does is it'll grab either parts of the model and just pull it and drag it out. And if you have to adjust the strength, I think, Brayton, and just bump the strength way up. And we'll talk about strength and size in just a second. but you can actually pull and push and smush the model with the grab tool. And then the last button, or the rather not, sorry, not the last button, the final row here, the next button is inflate, and that actually allows the brush area to swell outwards like blowing up a balloon. Next to inflate is pinch. So the opposite of blowing up a balloon, it'll sharpen things to a point. And then finally, the final button here is smooth. So that'll relax the surface of the brushing or the brushed area, and it'll blur details and it'll smooth things out. So we've covered all 9 of the tools, and I think it's kind of best to let you guys start experimenting and playing around with those and finding out your favorite. But there's only a couple more things I want to teach you before we'll start talking about engineering in general. So grab is my favorite tool. It's the one I use most often, so I think we should probably select that one first. And there are 3 settings here that we need to know before we truly get started 3D modeling. So if you look right up to just to the right of your tool, so just right up to the right of the word grab, there's a size and a strength button. So if you change the size, it'll change the size of that brush. And we already did that before by holding Shift and rolling the mouse wheel. But you can also do it by manually dragging that size bar at the top. And right below size is a button called strength. And what strength does is changes the strength of the brush and what that brush does. So if you have the grab tool and you have a higher strength, it'll grab more clay a little easier. If you have the draw tool enabled, higher strength means you'll draw a taller line. If you have the crease tool, what it'll do is dig a deeper crease into your model. So together, size and strength play together to make sure that your model or that the brush is acting in the way that you want. So the strength is kind of like how hard or soft you'll be digging into that digital ball of clay. So we'll start with the grab tool. And we'll just start 3D modeling here. There's one more thing I want to show you guys. There's one more cool button, and it only applies to the rotate, the scale, and the grab buttons. So if you click any one of those buttons and you turn on a setting called global, what it's going to do is turn off that brush circumference. We can't see that circle, that orange circle is there anymore, but what Brayton is demonstrating is it'll actually move not just the brush area where you had, but the entire model. So that's really important if you have multiple objects, so multiple meshes in the same area. So let's add a second sphere to the scene. And what you'll actually see is 2 spheres pop up. So let's give it eyeballs. And if those eyeballs are way too big, you can make sure that your scale is on. And as long as global is checked, you'll move and change the entire scale of the object. So you can do that. You can rotate the whole objects around. You can grab them and move them in place a little bit more. So with global toggled on, that's how you can start moving things around and putting them in their proper spots. So that's kind of it. One of the things you can see that Brayton's doing, and Brayton's going to be just sort of free designing while I talk to you a little bit more about engineering. But one of the things that you can do is start all new spheres by hitting, and if you saw what Brayton went to, he went to the sphere button, and instead of hitting sphere and add object to add a sphere to this model, he hit new scene and he started again. So you can do that as well. Anytime that we are modeling this stuff, we really like to keep symmetry on. And the reason being, if we're 3D modeling something like a dog or a face, it's really easy to do 2 sides at once. But you can turn off symmetry if you really want to make something asymmetrical. It's really just important to know that once you turn off symmetry, it can goof up your model if you try and turn it back on afterwards. That's where maybe you need to have global on to adjust things accordingly. So that's kind of the toolkit. Use this stuff, and I hope that's pretty clear. But if there's anything we need to clear up for you guys while we talk about engineering, post them in the comments. Brayton and I can help you and answer questions, but this is where it gets sort of interactive and fun. You can model whatever you want. So I think the big question of how does 3D modeling relate to engineering stems from the question of what is an engineer? So chances are, if you're like me, you're sitting in a chair or a sofa that was engineered, in a room that was engineered, in a building that was engineered, while looking and talking to people on a computer that was engineered, or a phone or a tablet or a TV that was engineered. So who do we know that made all of these things possible? It's not a trick question. Engineers made those things possible. So engineers are the ones who dream up a lot of the things that you use every day, from toys to tools. So an engineer is really someone who studies how and why things work by using math and science. And engineers are some of the most curious people around. So if you're also curious and like to solve problems and puzzles, you might make a great engineer. And so engineers are always learning about how things work because they design and build things themselves, things that solve problems. And there are lots of different kinds of engineers that you can be, but they all have the same basic job: inventing and building things that solve problems for people. And all engineers ask themselves three really important questions when they're working. Question number one: what's the problem that needs to be solved? Question number two: who has the problem that needs to be solved? And then finally, question number three: why is this problem important to solve? So engineers solve problems with their inventions. They want to know how and why things work, and they have really special training that they use to make practical things. Engineers often specialize in various specific branches of engineering. There are a bunch of different branches of engineering, but the main branches are civil engineering, mechanical engineering, electrical engineering, and chemical engineering. And my friend Braden is actually, he's majoring in mechanical engineering with a minor in electrical engineering. So he's a really smart guy. But first, let's talk about civil engineering. If you're interested in designing and constructing buildings, bridges, and roads, then civil engineering is the branch you might want to study. So the Great Pyramids of Egypt, the Great Wall of China, the Brooklyn Bridge in New York, the Hoover Dam along the Colorado River are all really great examples of civil engineering. And so if you've ever seen reruns of the show Full House, the Golden Gate Bridge in San Francisco, which was designed by civil engineers to stand up to really strong winds and earthquakes, is an excellent example of something created and designed by civil engineers. Next up, just like Brayton, if you like engines or tools or machines or bikes or cars or any type of powered system, mechanical engineering might be another interesting type of engineering to explore. So you might have heard of a guy called Henry Ford, as in Ford Cars and Trucks. And Henry Ford was a mechanical engineer. And importantly, Henry did not invent the automobile, but the Ford Motor Company made a lot of vehicles. So his Model T car was famous for being really affordable to plenty of Americans. So Henry Ford saw that lots of people wanted to drive this newfangled car, but they couldn't because they couldn't afford the pricey vehicles that were for sale. So Henry Ford engineered a cheaper model to solve that problem. So now another example is the elevator. So an elevator lets you go up and down buildings fairly easily, and that's a great example of mechanical engineering. I certainly would hate to live on the 100th floor of a building and have to carry groceries all the way up and down the stairs. I would be exhausted, but very, very fit. So if your problem involves needing to go from one place to another really quickly, bikes and cars and elevators are solutions to that problem that mechanical engineers came up with. And then next up is electrical engineering, which is the study and design and development of electrical equipment. So electrical engineers, just like Brayton, design electrical systems like circuits and computer chips. So think of all of the things you might use quite a bit. For instance, your microwave, So a microwave solves the problem. How do I heat up this cold pizza at midnight quickly and easily? But electrical engineers are not just master microwavers. Um, they're the designers and creators of things like computers and laptops, cell phones, lights, and even robots. Those are all awesome examples of electrical engineering. So, like me, the final one that I just want to talk about here is chemical engineering. And if, like me, you've ever blown a really big bubble with bubble gum, chances are a chemical engineer helped to design that, which sounds sort of funky, but chemical engineers also develop and produce vaccines and treatments for people who are sick. Many of the objects that we use every day contain substances that were discovered by chemists and that were designed and refined by chemical engineers. So whether that's the table that we're sitting on, are sitting next to, the clothes that we're wearing, the food that we're eating, somewhere along the line, a chemical engineer probably helped to make that possible. And so there's a couple more types of engineering that we'll talk about next time when we talk about the engineering design process. But one of the things I wanted to talk about today, what engineers are doing to help stem and stop coronavirus. So you might have seen all of the face masks and face shields that people were 3D printing. And a lot of those were designed by engineers working alongside scientists to make sure that the masks fit really well and blocked what they needed to block, like people sneezing and coughing and accidentally spreading COVID-19 droplets, which isn't great. So there's currently a shortage nationwide of different types of PPE or personal protective equipment, which is why whenever you guys go to the supermarket, wearing your handkerchiefs and homemade masks, you'll also see other people around you wearing handkerchiefs and sewn masks or 3D printed masks. And that's because engineers all over the world have been working to come up with really clever solutions to problems. And so the problem right now is, how can we help out these big manufacturers produce things like PPE so they can catch up and produce the real PPE that doctors and nurses wear? So with that, I think we have only a couple minutes. So if you guys wanted to, we could maybe field a couple questions for you, and then next time we'll be able to talk about how 3D printing works. And if you guys are working on some cool models, one of the things we'll be able to do is 3D print them right in front of you, and we'll talk about the engineering design process. So more things that 3D printers, including some that we'll take a look at, are doing to help, what we've made with our 3D printers to help in this effort, what 3D printers around the state and around the world are doing to help, and then any other questions you guys might have.
Awesome, Tyler. So we do have a question. So this question is from Avery, and what she asks is, what materials can you 3D print with?
So that's a really fun question because the answer is really wide and varied. So you might see there's a 3D print like this, and this is made out of a plastic, and this is like a cornstarch based plastic. But there's other things. We can 3D print in rubber, so like a Lego tire like rubber. But the other thing that we can do is nowadays they can 3D print in metal. They can 3D print in surgical resins that we'll talk about on Thursday. And they can even 3D print in food. So broccoli paste and dough and chocolate, if you can believe it.
Wow, incredible. All right, so I think, Tyler, you've spoken about what we're going to be doing on Thursday. Should we check in with Brayton and kind of see what progress we have going on there? And let's see what happened, like what Brayton was able to build in Sculptress in 30 minutes. Let's take a look.
Sure, yeah. Let's go over to Brayton and see if he wants to talk about what he was making.
I was just kind of free modeling there. Decided to kind of start with a long face, and so I decided that it kind of looked like a rat, and we were going to go with the rat because it was fun. So,
so in 30 minutes, you can see that he built this from scratch. So is a 3D modeled rat necessarily related to to COVID-19? Not so much, but what if you wanted to make a special mask for your pet rat? You'd start with a 3D model, and you could make the mask around it and then 3D print both, which is pretty cool.
Thank you so much, Tyler and Brayton, for joining us this evening. As you guys saw, how cool, using a free 3D sculpting software to start playing around and modeling and building things. Because what Tyler and Brayton are going to also, again, show you on Thursday is how when you design something in Sculptris, how we can potentially have a 3D printer print it. And as you guys know, these are really cool machines, and you have an opportunity to win one for your school, which would be really awesome. And Tyler also spoke about we can print in things like plastic and chocolate and food. So just endless options for you guys in 3D printing, and it really truly is the future. So you're beginning to see the future. So if what you like tonight, the code word may have shown up, maybe it didn't, I don't know, maybe it'll be Thursday, hopefully you were watching, but definitely make sure that if you download Sculptris, if you look at the description of this YouTube video, there's links for both the PC and Mac. You can download it for free and rewatch this video because this is recorded, so you can get another little tutorial. So we highly encourage all of you to play around with Sculptris so that when we come back this Thursday, 6 p.m. live for part 2 of 2, that you guys will have some 3D models. And then also, again, don't forget, I'm just going to put that email here back on that screen, which is when you have your Sculptris model, you can send a little thing to info@wtcc.tech, and we will then take a look at that and go from there. So thank you all so very much for joining us for WYSTEM once again, and we look forward to seeing you this Thursday, 6 p.m. for part 2 of 2 for Engineering Week. So until then, everyone, have a great night, and we'll see you back here soon.